Hello guys, this is Jack again. I'm a math and electrical engineering tutor from the Chegg. In this video lesson, we are going to study binary numbers. Before going into the binary numbers, let's recall about some basic number we have been using to deal in math. Natural numbers are any number from 0, 1, 2 up to infinity. Negative numbers are any numbers that are less than 0 but not including the 0. Integers, a natural number, a negative number, or and a 0. So for integers, it can be anything 0 or anything less than 0 or anything bigger than 0, but it has to be a whole number. In addition to that, we also have rational number. So rational number has the form of Q over R, fraction. So any number can be in the rational number can be represented as Q over R, where Q and R belong to the integer, but the R cannot be 0 because you cannot divide something by 0, which is undefined. So these numbers are only meaningful if we assign them to a numbering system. You have been using these kinds of numbers for the calculation in math, in calculus class, in trigonometry, mostly all of the classes that you are dealing with. But have you ever noticed that these numbers are base 10 number? We call it base 10. Base 10 because there are many types of base in a numbering system. For example, we have base 10, base 2, which is the binary number we are going to deal soon. So this type of number we call it base 10. And what it means in base 10 is that if you have some number, for example 515, and you can factor or you can write it as 500 plus 10 plus 5, because this component is a fraction of 10, as you can see below here. The base of a number determines the number of the digits and the value of the digit positions. Okay, so for 515, as I mentioned, we have three components: 500 plus 10 plus 5. The reason that I write it this way because these three numbers can be factored into some number, some constant, times with 10 to the power of 10. So 500 equal to 5 times 10 to the 2, which is 5 times 10 to 5 times 100, which is 500. And 10 is 1 times 10 to the first power, or 10. And 5, which is actually just 5 times 1, but 1 is 10 to the 0. So in base 10, the general form is that you have a multiply 10 to the power exponent, and the exponent can be 0, -1, and then -2. This one is an integer, and the coefficient is the integer also. So in base 10, we use this kind of system to do all kind of calculation in math and calculus class, physics and stuff. And now let's move on to study another type of numbering system, which is binary numbers. And why do we have to study the binary numbers? In computer science and electronic engineering, digital computers are made up of electronic circuits, and these electronic circuits only have exactly two states, on or off. Computers use a numbering system which has exactly two symbols representing on and off state. So we define another new type of number, which is the binary number, and the binary has the base 2. It has only 0 or 1. The reason we choose 0 or 1 because it's easier to for the computer to store the data and understand on its own language, because the computer has their own assembling language, and the binary is a way that the human input the stuff so that the computer can understand. But a binary number or binary digit or the bit can take only two values, 0 or 1, and usually 0 represents for the low voltage, and high voltage is represented by 1. By low voltage, we mean in digital circuit we have usually we have the waveform function of the clock. The low state or the 0, or the high state is 1. We call it 1. So 0, that means we have no electric current flowing, or the current is 0, or the voltage is 0. We don't have any on state. And if you have 1, that means the system is on and you can pass the current, the voltage, to the circuit. And then you can also think of it as a switch. When you turn on and off the switch, if you turn on the switch, it can represent it as high voltage or level 1. And if you turn off the switch, of the circuit, you close the switch of the circuit, that means the voltage is 0. I mean, the voltage is 0 if you open the switch, like you are not closing it, you open it, you make it has an open circuit here, so no current is flowing, so you are at low state or 0. And if you turn on the power or you close the switch, you have the high voltage state, which is 1. So this type of numbers, the computer, they use this and they understand this instead of the base 10 that we use for the calculation in the outside world. So those are the basic definition of the binary number. Now we need to have some example to understand more how the base 10 and base 2 are related to each other. Example number 1. For example, you have 1, 0, 1, 1 in base 2, and you want to know what is this value, numeric value, in our usual base 10. So here's the method to convert that base 2 into base 10. Remembering that if you have 1, 0, 1, 1, the last digit corresponding to the power of the exponent or base 2 exponent. So 1 here, you write 1 and you multiply with 2, and then because this is the last one, you take it with the 0 exponent, and the next one is 1. So 1 is in the first position, so you plus with 1 multiply 2 to the 1, and then again you plus with this one that in the second position. So this is 0, so 0 multiply with 2 to the 2, and then the last one here on the left, which is 1 times 2 to the third power. So remember, from all the way to the right, you have 2 to the 0, and then 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and then up all the way to the left. So with this order, you can convert anything from the base 2 system to the base 10. If you see the 1, you take that, you multiply with the base 2 and then the exponent. If you see 0 and you take the 0, you multiply with the same thing in that location. Another example, if you want to convert the binary number to the decimal for this case, okay, so we have 1, 2, 3, 4, 5, and 6. So 6 digits or 6 number. So you want 1, 2, 3, 4, 5. Okay, you need one more, 2 to the 5th. And then the last one is 1. So we have 1 multiplied with this plus. The second one also 1. So 1 multiplied with that. And then this is 0. So I have 0 and then plus. This is 0. I have 0 plus with the next one. This is 1. So 1 multiply this. This is 1. So 1 multiply with that. So remember, the rightmost number is 0. The power. So you go from 0, 1, 2, 3, 4, 5. And we have 1, 2, 3, 4, 5, 6 numbers. And you have here 1, 2, 3, 4, 5, and 6. So now this one is just 1. This one equal to 2, right? And this is multiplied with 0, so it becomes 0. This is 0 also because you time with 0. 2 to the 4 is 16. And then 2 to the 5th, 32. So plug them together. This is 48, 50, 51. So in base 10, you're gonna get 51. But if you want to enter the 51 to the computer, and then in order for the computer to take the value 51 to do the calculation, they have to convert the decimal to the binary first, because all the calculation can be only done in the binary system. Okay, so now another example. So we go from the binary to the decimal. What happens if you want to go from the decimal, which is the base 10, to the binary? In for example, you have some number, I would say 10. How do we go from 10? Oh, I don't want to choose 10 because 10 is 1 0. It can be misunderstood with the binary number. Let's choose 12. Okay, how do you convert 12 in base 10 to the binary, which is base 2? So 12, again, first you have to write something like this first. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and then you check. 2 to the 3 is 8. Okay, so this is 8. 2 to the 2 is 4. And you see 8 plus 4, which is 12. That means you only need 4 bits in order to write 12 as a binary. So 2 to the third power is 8. 2 to the second is 2 squared is 4. 8 plus 4 is 12. So these two guys are sufficient to convert to binary. So in this location, you want to have the coefficient of 1. You don't want 0 here because binary either 1 or 0, but you want to take the value of this because you want 8 plus 4, and if you want these guys to plot together, to add together, then you have to let the coefficient 1 here, because if you put 0, then 0 times 8 becomes 0. So the value of 8 go away. So you want to have 1 here, and we already reached to 12 that we want. So the rest, you don't need the value of them, so you put 0. So finally, 1 1 0 0 is the binary system base 2 for the base 10 number 12. Okay, so the last example, let's do one more practice on converting decimal to binary. So now let's do another big numbers. For example, 150. You want to convert 150 in decimal base 10 to the binary base 2. So again, I write 2 to the 0 first, 2 to the 1, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6. You want the leftmost bit that has the value close to 150. Okay, because if you choose to stop right here and it has only 3 bits, and 2 to the 3 is only 8 plus 2 is 10 plus 1, which is 11, and 11 is much less than 150. So you have to extend the bit all the way to the left. So 2 to the 0, 1, 2. Oh, we are missing 1. So 1, 2, 3, 4, 5, 6, 7. And then let's see. 2 to the 7 is 128. How about 2 to the 8? 2 to the 8 is 256, and 256 is bigger than this, so we don't take this value. But 2 to the 7 we take it. It's 128. Okay, so 128, how much that we need to add 128? So to get to 50, which is 22, right? 22. So you need to add 22 more to get to 150. And let's see, this one is huge. It's bigger than 22. 2 to the 6 is 64, right? And 2 to the 5th is 32, is also bigger than 22. And so 2 to the 4 is 16. Okay, so this is 16. So 16, so we need 6 more to add up to get 150. So 6 more, and 2 to the 2 is 4. So we need 2 more, right? 2 more, which is 2 to the 1 is 2. So 128 plus 16 plus 4 plus 2 is 150. So in this location, you need to put the 1 because we want to take the value of this, and we want the value or the state to be on. So you put 1 in here, and then the rest you just put 0 because we don't take their value. So finally we can write it in nicely way like this: 1 0 0 1 0 1 1 0. So 150 in decimal can be converted to binary with 1 2 3 4 5 6 7 8 bits. So here is 150 in the binary base 2 numbers. So that's all the basics conversions between decimal and binary, and the relationship between them, and why we have to learn the binary. Okay, so that's conclude the lesson today, and I hope you enjoy that. And if you do have any question, you can comment on the YouTube, or you send me an email to my profile if you have any question, and I can be explaining to you. All right, thank you.